Hello, Lana. This is Mr. Odingo. I'm bringing you a very good news today by trying to look at what an atom is. And last time we talked about element, there was not much really to say. But today, I think we are going to really have a very nice lesson, and I invite you to pay attention so that we learn together. Atoms is something very important in chemistry, and this area we have to understand for us to move on successfully. If you have to score high grades in chemistry, you can't do it without understanding what an atom is. Now, elements that I said are 118. Each of these elements is made up of the smallest unit called atom. Now, an atom, I've drawn something like circular structure here. I'm going to use this one to represent an atom, although an atom is spherical, it's not circular. But now, because I cannot be able to draw a spherical structure on the board, I've drawn a circle to help us understand how an atom looks like. And the way I've drawn an atom, you can see that it has two parts. An atom has two parts, and I'm going to name them. This part here is called nucleus. And the other part here is called the energy shells. Energy shells. Or we can say energy levels. Or we can say orbitals. We can say orbitals. So those are the two parts of an atom. So every element is made up of an atom. And there's not just one atom. There are millions and millions of atoms that come together to make an element that we can be able to see. Now, this atom, the way you see it, it may vary. The atom of hydrogen, for example, is the smallest. If you compare the atoms of the first 20 elements, we can say the atom of hydrogen is the smallest, and the atom of calcium is the largest. And that is why it's a little different. We cannot just say they have the same identical atoms. We can also not be able to say that each element has this identical atom. That will be not true, because we are going to learn something called isotopes, and we are going to see that atoms may be different in some way because the neutrons in the nucleus may not be the same. But what we can say that every element has atoms with the same atomic number, and we are going to see what atomic number is. So today, if we are asked to define what an atom is, what can we say? We can say an atom is the smallest part of an element. It's the smallest part of an element that can take part in a chemical reaction. So yes, we have the name element, but what is actually reacting in that element is that small part that we refer to as an atom. Here it is very big, but an atom in real life situation cannot be seen, cannot really be seen. So an atom is very, very small. Now, I've defined what an atom is as the smallest part of an element that can take part in a chemical reaction. We have seen the two parts of an element, of an atom, that is the nucleus and the energy shells. I want now to look at what we call the subatomic particles. These are the smallest particles that are found inside an atom. We call them subatomic particles, and there are three subatomic particles. One is called proton. The second one is called neutron, and the third one is called electron. These are the three particles that are found inside this atom. So briefly, I want to be able to explain the properties of these subatomic particles. And this table that I've drawn here is so that we can be able to understand. So here we'll start with protons. The second I'll go for neutrons. Then thirdly, I have electrons there. The properties that I want to start with, the first one, I want to start with the location. Where is the proton located? The proton is located in the nucleus. So we can say location is nucleus. What about the neutron? A neutron is also located in the nucleus. And electrons is now going to stay alone in the energy shell. So this one is energy shells for electrons. So in terms of location, both protons and neutrons are located in the nucleus. We can actually find them here. That is where they are found. Then the next thing I will go for electric charge. Electric charge, we want to look at, are they positively charged or negatively charged? And we can say that protons have positive charge. So one proton has positive 1 charge. A neutron, the name is derived from the word neutral. So a neutron has no charge. We can say it has 0 charge, no charge. It is neutral, so there's no charge that a neutron has. What about electrons? It's the opposite of protons, that is -1. So one electron has -1 charge. Then I want to move to what we call mass. We say proton is too small, we can't measure and see really mass in an electronic balance that we use in the laboratory or at home in the kitchen. But we have a unit of measuring it, that is atomic mass units. We use the word atomic mass units. Atomic mass units, AMU, or sometimes is written by this symbol. That's what we call atomic mass units for these small particles. The mass of a proton here is 1 AMU. But sometimes in an exam, I advise you just to write 1, because the examiner understands what you mean by 1. A neutron and a proton have the same mass, so we also have 1 AMU. An electron has the lowest mass of 1/1840 AMU. So you can actually see that the masses of proton and neutron are equal, but the mass of electron is 1,840 times smaller than proton or neutron. So this is the subatomic particle with the lowest mass. Finally, Lana, I want to talk about their symbols. Symbol, and the symbol for a proton is small p. Do not write capital P, because capital P is a symbol for phosphorus. The symbol for neutron is small n. I also insist don't write capital N, because capital N is for nitrogen as an element. And finally, the symbol for electron is small e. Lana, this is how far we can go, and I invite you to be able to study this table. This is very common in examination. It will come the way it is here, and they will require you to be able to fill the blank spaces or actually fill the whole table. Thank you, viewer, and in case you have any question, please make sure to subscribe and be able to ask the questions that you have, so that you can also attend to your needs.